Hi guys, hi everyone. Welcome back to my YouTube channel. This is day two. Yeah, this is going to be the day two video of what we started yesterday under code review. And we are using the platform codereviewlab.com, a place where you can come and learn code review on different types of web vulnerabilities and how to check for bugs there before deployment. Now, this video is solely dedicated for application security testers, engineers, and bug bounty hunters. And if you are a developer, this video is also meant for you, as you will learn how to actually check for bugs in your code before deployment. Now, we started this video yesterday, and part one is actually yesterday. I didn't indicate it on its part one, part two, but the first video was yesterday where we touched JWT vulnerabilities and we identified some flaws, answered some questions, and also we recognize some patterns and practices we can actually do in securing JWT vulnerabilities when we come across them during code review. And for today, we are going to be going into the broken authentication code review guide. And once we are done with this, we are going to be solving some labs under port trigger in authentication, probably two or three labs in authentication. So you can get your bug suits ready as you're watching this video, as we'll be touching those aspects and explain why these flaws are actually there. Now, let's begin from here. This is going to learn us to teach us how to identify and prevent broken authentication vulnerabilities, including weak passwords, session management flaws, credential stuffing, and account enumeration. Now, this is actually updated 2026-05-15 as the fifth month this year. Oh yeah, on the 15th. That should be May. Yeah. So we're going to be starting from the introduction here. And broken authentication consistently ranks in the OWASP top 10 as one of the most critical web application vulnerabilities. When an authentication is implemented incorrectly, attackers can compromise passwords, session tokens, or exploit implementation flaws to assume the identities of legitimate users. Now, authentication vulnerabilities don't require complex exploits. They often arise from the simple mistakes like weak password requirements, predictable session cookies, tokens, or missing rate limiting. The impact is severe, complete account takeover, and access to all users' data. Now, broken authentication will automatically lead to broken authorization. That's just how it is. And authentication verifies who you are, that is the identity. Authorization determines what you can do, permission. So broken authentication allow attackers to become someone else entirely, which then bypasses all authorization control from that identity. Now, in a nutshell, what this is telling us is that there are some of the things that are not being configured well on the back end of the application or probably on the server that actually leads to broken authentication. And when this happens, an attacker can easily turn to another user or elevate privileges, because once an authentication is broken, there's very high chance that you can also there's also a broken authorization in that same application. Now, in here, they talked three different parts: credentials, sessions, and account recovery. So for the credentials part, we have weak password policies, and we know password should not be less than 12 characters, 12 random characters. Insecure password storage, default credentials, credential stuffing, and for the session, we have flaws like session fixation, session hijacking, insufficient expiration, and insecure session IDs. And for the account recovery, we have weak reset tokens, insecure questions, token leakage, and there is no rate limiting. This happens to also be a kind of API vulnerability, by the way, for any application. So for the impact for all these vulnerabilities that I just listed here is that broken authentication leads to account takeover, that is ATO, unauthorized access to sensitive data, identity theft, and compliance violations. Now, if any of these things are not met, they are not configured right, they are not met, is then it gives unauthorized access, and there are a lot of compliance violations like the passport policy is part of compliance violation, which means that your application needs to actually be in compliance. When you're doing performing code review, you have to check for all these things very well. So here I see which vulnerabilities class typically has the highest impact. We have cross-site scripting, broken authentication, missing security errors, verbose error messages. Broken authentication tends to have the highest impact, then followed by cross-site scripting. But today we are touching authentication. So here we have password security. Password security encompasses both how passwords are validated during creation and how they are stored. So weak policies and improper storage are among the most common authentication flaws. Again, weak policies and improper storage are among the most common authentication flaws. So this is actually one of the most common authentication flaws, which actually leads to um, bypassing someone's account without using password because there's a weak password security, and probably it's easy to enumerate. Who knows? These are the kind of flaws we find in authentication, and according to the OWASP AppSec community, they tend to rank authentication every year. Also, it's also part of the top 5 vulnerabilities in the OWASP top 10, always part of the top 5 vulnerabilities being found in applications over the last 5 years. Now, this is a vulnerable password pattern. This is a JavaScript code, and this is a vulnerable JavaScript code, and the password security here is actually extremely low. So with this is a secure one we'll be looking into to compare with the insecure password pattern. Now, vulnerable, no password requirements. Now, this is an app post, register. When you register, send the request, username and password. No validation, user code, get password to, could set password to 1. So in this case, password should actually have a kind of limit of 12 characters. You get the length. Um, in this place, and then the second part where there's a vulnerability is weak password policy, easily bypassed. So there's no password policy, and this place is saying password length less than or equals to 6. That's too short. The standard policy states that your password should be 12 characters, 12 or minimum of 12 characters. And here, storing plain text password. This also, you can also say you are giving this hard coded credentials. So function create username password, then you insert into user password values, never store. So this is a kind of SQL code. Yeah, this kind of SQL. This is an SQL query. Insert into users. This an SQL query, database query. So this is using an SQL query, probably SQL, maybe no SQL, but this is an SQL query, and it's storing the password in plain text because you just give it the stuff straight away, that username and password. So if the storage is breached, it's easy to actually see these passwords, and that's going to be a very bad thing. Then vulnerable, using weak hashing. MD5 is broken, can be cracked in seconds. So you're using MD5 to actually hash your password. That's a bad thing. That's not a good way. You don't use MD5. You don't use base64 URL because this can easily be cracked and unveiled by attackers. And then we have a hashing without salt. Now, if you don't know the meaning of salt, then you need to go and learn about salt. Salting is one of the cryptographic methods to actually encrypt passwords, words, or anything. And salting is more of adding special character at the end of the encryption standard to make it more secure in that aspect. So if you can go learn more about salting in cryptography, so you can know about it. You can still learn about salting, cipher, plain text, and all of that. Encrypt, decrypt, so you understand what we are actually explaining here. Now, if you have not watched the previous video, I send you go and watch so you can know how we started this thing and how it's going. So you can also start this and start reviewing from your own end, which will actually give you a very good standard practice and knowledge in code reviewing. Now, code reviewing doesn't just happen overnight. It takes a very long time to understand how to review code because you won't be working with just one type of code. Now, this is just JavaScript, and we have other programming languages out there, other query languages out there, and we have PHP, we have Ruby, we have Python, we have Java. And you have to know how their authentication, their acceptance, their authorization, how it all works. So you have to have a very good practice in all of these programming languages. And this lab here actually covers all that aspect. It has a pro version, but the free version also allows you to check some of these programming languages and review their codes and know how they are done, how they are written. There's leaderboard, which means there's actually a kind of daily challenge you can solve to push yourself to understand more about code reviewing. Now, the secure password implementation. So here is the vulnerable code, and now we are having the secure code, and we're going to see how it's being done. So in here we have we didn't have a password validation here. No validation, password, no quick password policy, storing password in plain text, weak hashing, using MD5 for hashing. There's no sorting in the password. So same password equals the same hash. Rainbow table vulnerable. Funny. Rainbow table vulnerable. I find that funny actually. So here, let's go into it. Strong password validation. So you have your function here. We have the password length greater than 12. Good. An error pushes password must be at least 12 characters. That's the standard password policy. It has to be a minimum of 12 character for every password, for every strong password, minimum of 12 character. And here is a very strong password validation. So if it's not 12, it is not accepting it. That is a good one. That has been solved. Then check against common passwords. So if common password include password to lowercase, include password dot to lowercase, errors push. This is an if and else statement. So if you don't know if and else statement in JavaScript, you might have a hard time understanding the kind of codes. So code review is also about identifying them. You have to understand the code to actually know how it works. So if you are there's a kind of common passwords and all, this is actually a kind of would I call it a constant? Not a, I won't call it a variable, but this was actually let identify if a password is actually on very very common. If the password is too common. So if you put a common password, it validates that password and tell you that password is too common. Change your password. Even on your Chrome browser, when you register for an application and then you type in a very easy password, it will tell you that update your password. That is, your password is too weak. That's what the Chrome. Yeah, the updated Chrome now will tell you that if Chrome is not bringing it out for you, that's by putting in weak passwords, then that's you have to update your browser. And in every standard password practice, you have to understand that your password needs to have at least one or two capital letter or uppercase, lowercase characters and numbers to make it a strong password. So putting just a long name and saying Gabriel Odesanya or Gabitek at 01 and this or Gabitek 01, that's not a very strong password policy. Okay. So that's that on that. And check for breach password. So this actually, when checking against common passwords, it checks this have I been pwned API, awaits check breach password. So returns error. So this is an if statement that if a user inputs the password, it should compare it with have I been pwned API to check for the popular password that has been breached or if the password is common. Then it returns error for you if the password is actually common. Now we can actually go and check this right away on have I been pwned. Have I been pwned? Now, this is the place to actually check if your password has been breached one way or the other, or your email address has been breached in one way or the other. If you find your password to be in this have I been pwned, then it's required of you to go and change your password as it can be used to actually exploit you at any point in time. So this is for email. The password should be down. All right, is it try no now? All right, passwords. Now, this is the API. You can connect it if you are building your website or web application or so. You can connect the API. So it can just run checks on it before doing stuff. So this is the password. So let's say a password and say 1234. Now I type 1234. That's for password. Of course, you will see to tell me this password has been breached because this password is not actually a strong password. So, oh no, pwned 30 million times, 30.3 million times. This password has been used 30.3 million times and has been found in the hackers database of like pwned websites, pwned applications, and they've seen that, yeah, 1234 is no longer a secure password. So let's try another one. Let's try the password I normally use. Let's see if my password has been pwned. So, okay, let's check if my password is still safe. Oh, good. Now you see my password is actually there, is still safe, totally safe. It hasn't been pawned, it hasn't been used by any attacker in any way, and that's all. And you can also check for the other time we saw you can check for your email and all and check how if this email or this thing has actually been pawned. This is actually a very good website by the way to check for your password and all if it has been pawned. They also have a pricing. You can go into it and run your checks as you best see fit. So let's continue from where we stopped. Now we've checked for passwords, and now we see that the passwords is correct. The password length is also in there. The password length policy is also there. Now the secure using bcrypt with proper cost factor. Now bcrypt rounds. This is now not using MD5 for your hashing. This is using bcrypt to actually hash, not hash, but part of what is actually going to hash the passwords. So okay, this whole thing is something else. This is a code actually has to understand. So of course you run into issues like this. So you can always do well to copy it here and go to GPT or something to actually verify what that code means. So in case you come across any code you do not understand fully, you can always check for that code and see why the code is not understanding for you. Perhaps you haven't gotten there yet, but you can always check, you can always ask around for explanation on that particular code. Now, I know bytecode is to something like encryption or something, but I'm not understanding the whole full code, so I have to check what it means. Looks like the network is not going. Oh, my bot is on, so that is to be expected. All right, let's leave that aspect. But we can see here password hash. So it's relating back here. All right, yes, yeah, it's coming back. It's coming back here. So constant argon to require argon to hash password, hash password. Now instead of using MD5, this is actually hashing the password and encrypting it. Instead of using MD5 or base 64 URL, which is actually not accurate. So this password hashing algorithm is actually follow and don't should not follow. So MD5 security is broken, never used for passwords. SHA-1 broken, never used for password. SHA-256 fast but bad, not designed for password. Bytecode is good, script is good. Hagon2 ID best recommended PHC winner. So actually, so I think the best hashing password hashing algorithm that should be used is Hagon2 ID. So let's say you are actually in a room with developers, you are in a room with builders, and you're building a software and application. You want to encrypt your password, you want to hash your password, and some are bringing in the idea of using MD5 to encrypt the password, or are bringing the idea of B64 or SHA-1 or SHA-256. You can easily come in and say, oh, we can actually use Argon2 ID. This is best recommended hashing algorithm to use for passwords. We can't use MD5 because it is not required for password, as it can easily, be decrypted, be broken down, and can just find a way around. Attacker can find a way around it. So this will actually give you very good knowledge in what you are building if you understand this code a lot. So it will be more easy for you to relate with developers and assist them. That's what I will use in building a secure application and software. I mean, it's not all the time an AppSec engineer has to fight with the developer before they get this done. Okay. Now, where SHA-256 not recommended for password hashing? Yeah, it's fast, allowing rapid brute force attack. It's not supposed produces cryptographic. I think this should be the answer. Yeah. All right, now checking the next one in broken authentication is session management. Now we check for password security, which happens to be one of the most common. And now we're checking session management. Now, session management happens to be another way that attacker actually bypass authentication to get into an application and have access into what they're not meant to have access to, of course, because you're breaking into another user's account and having access to something that is completely not yours. So session management determines how authenticated state is maintained between requests. So flaws in session handlings can allow attackers to hijack legitimate user sessions or fixate sessions to known rules. So session fixation and session hijacking. So this session fixation, now let's explain it. Let's see what it actually means here. So attacker gets session ID from server. Attacker sends victim a link with that session ID. Victim logs in. Session becomes authenticated. Attackers use same session ID to access the account. Now, session fixation is probably when it's not rotating, it doesn't have any time limit, it doesn't have any TTL, that is time to leave. And session hijacking, victim logs in and gets session ID. Attacker steals session ID through probably SSS or network sniffing using tools like Wireshark or something. Then attacker replace session ID. Attacker has full access to victim's session. So there's actually a very strong hold when you're checking for authentication in code review. You check the password security, and now you're going to check for the session management to see how the session operates. Now, this is the session vulnerabilities, and here's the secure session implementation, and we're going to be checking it now. On this aspect, on this end, vulnerable predictable session IDs. Now, function generate session ID, return date does now dot to string. This is a predictable session ID because it is going to be showing the present date of when that session was created and turning it into a string. Of course, an attacker can easily identify that. So it's as well as saying, where can I type something? I need to use a kind of notepad to explain this further. All right, notepad. I should probably use a whiteboard to explain things like this, but yeah. Okay, so session ID, when you are using return date does now to string and turning it into a string, is as well as saying All right, today's date is 14, I guess. Yeah, today's 14/08. So we say 14/08, 2026. And the time is 5:26 p.m. I'm doing 5:26. Yeah. Now this is one session, and then turning it into a string will be just adding the apostrophes. Now this is your session. Of course, it is predictable. An attacker looking into it to just identify and say, all right, this is today's date, this is the month, this is the year, and this is the time it was created. It will easily it can easily be taken down. Of course, it's predictable, and this is not advisable. So vulnerable sequential session IDs. This sequential session IDs. So let session counter equals 0, function generate session ID, return plus plus counter to string. It's also guessable. It's also very, very guessable. This is guessable sequential because the counter is actually 0. I don't know how to explain this further, but if your session ID is sequential, don't worry, when we check the secured one, we'll be able to explain this vulnerability very well. So session fixation, no regeneration or login. Like, no. This, nah. Nah, because what this is saying is that, all right, let's look into it first. So you log in, request, response, your name and password, and it gives you your body. So if authenticates username password, session ID remains the same after login. I mean, the same session ID you used to load the browser to put your password and all is still the same thing after you log in. This thing is meant to rotate. Now, this session fixation causes a lot of damage. If an attacker actually gets the session, you can also get in, because I'm very sure this session ID will also be in that same session, and can be used to get in, because now we can guess what has been there. Of course, the password might also be written. The password and username can also as well be there. Yes, the username and password is always on session after you authenticate, and getting that session is going to take a lot of damage. So it doesn't have to be fixed. It has to regenerate on login, after login. And even if you're having different parameters, different endpoints, it's meant to be rotating and spinning. And also, it must have a time to live. I mean, it should have a time to live. If it has a time to live, then it won't be an issue. So this is the session never expire. Cookie, no max age and secret. I mean, this just rubbish. You will even see this makes no sense. This old codes here makes no sense. It makes no sense. There's no assigning a time for it that all right, after this and this, it should actually change or request a login back into the application after an amount of time. Now we have here again session ID in URL. This is bad. Now, of app.get dashboard, the session ID require session seed. So leak VI referral. This is bad because it means in your browser you'll be having your session ID, and your session ID, remember, it's actually this. This is actually your session ID, predictable, and then it's appearing on your browser. It can as well be sniffed. It can as well be taken through cross-site scripting. In most cases, it's been taken through cross-site scripting. And when an attacker actually gets that, that's the end. So you have to actually understand this code very well to understand what I'm trying to explain here. Now, vulnerable, missing secure cookie flag. There is no secure cookie flag. There's no HTTP only. There's no secure only. There's no all these security headers to actually keep things in check are not there. You see, missing HTTP, secure, same site, all of these are not there on the header. That's going to be a bad thing. Let me kind of bring let's bring let's see. All right, cookie. I'm trying to look for the same site to see if we can actually get it. Oh, it's not here. But when we solve the lab, we shall see what I'm trying to explain. So here's the secure implementation for session management. Now, constant section require express session. So secure session configuration, here is how it should look like. It should have an header of HTTP only, secure, same site, max age, that is time to live. This is 36, 360, nah, 3.6. Hold up, 3, 3, yeah, 3.6. 3.6, 3.6 million seconds, I guess. Yeah, that should be 3.6 minutes. That's 1 hour, by the way. And HTTP only, prevent SSH access. HTTPS only. So this means that this secure only makes this application to work on only HTTPS, that is Hypertext Transfer Protocol secure, not just Hypertext Transfer Protocol. It means, and in this case, it means the TLS is actually there. So everything being transferred is encrypted during transmission. This is what you should understand. And what else do we have here? Secure regenerate session on authentication change. So after the login and all, and you get in, there should be a regeneration of session that should be used during when you are in your privacy, your dashboard. After it directs your dashboard or something, you should have a new session regenerated. So we have here, if our session username and all, then session generates this status 500 if it's trying to reuse that session. Of course, after authentication, and then you're trying to reuse the session again to bring a 500 for you. That's internal server error, does not exist or something. You have to, you know, log in the normal way. You can't just use the session to come in again. Now, destroy session, destroy session on logout. After logging out, the session should be destroyed. The session shouldn't be reusable even after you log out of the application. This is a valid thing you should do, because after you log out, you just see that your application is still operating without you knowing. Meanwhile, an attacker has actually gotten hand on that session and is now using it for his own basic use. So that's on that end. Then secure implement absolute session timeout. Session timeout const max age this. So after the login and all, there should be a particular time where the session will time out, and then you'll be required to log in again to re-authenticate into the application to still verify that it's still the same user that is using it and to keep the session in check. Now this is how it look, and you see in most secure codes they're usually longer than the insecure ones. Yeah, that's how it is. But I think in TypeScript it might be shorter, because TypeScript makes things easier than JavaScript in that case. Now, what's session fixation? What's session fixation? Attacker sets victim's ID before login, then uses it after. Yeah, I guess. So let's read about it. It says the attacker obtains a valid session ID and tricks a victim into authenticating with it through link. Then after login, the session becomes authenticated and the attacker can use the known ID to access the account. So we've touched two aspects now in authentication: password security and session management. Now on the third one we'll be looking into is brute force and credential stuffing. Now this is where we start using things like intruder on Bob's suit, trying to enumerate password or trying to enumerate this. Oh, we have an enumeration here. All right. Let's see what this one has for us. Now, without proper rate limiting, attacker can try thousands of password combinations, that's brute force, or use leaked credential database to find valid accounts, that's credential stuffing. Now, we'll be touching this in the lab we'll be solving on Postfigure. I'll be demonstrating this brute force and credential stuffing, and also the password security, I guess, or maybe the password reset flaws. We'll be checking the password reset flaws. So what would let's just understand this one first. So brute force and credential stuffing. In here it says let me just explain what rate limiting is. Now, rate limiting is a kind of API vulnerability also found in the OWASP API top 10. Yeah, excuse me. Yeah, all right. Also found in the OWASP API top 10. Now, rate limiting is when you are trying to submit multiple requests at once in an application, probably in the login in most cases, the login factor, when you're trying to log in your username and password, and then using a tool to automate this credentials. You use the tool to submit multiple requests at once. Now, if rate limiting is in that application, then after about 5 to 10 requests, probably within 10 seconds, it will lock you out and tell you to try again after probably 1 hour, or probably after maybe 2 hours or 24 hours. Some even say come back in the next day before you can continue what you are doing. Now that's rate limiting. It locks you out after you try to submit multiple requests at once, because if there's no rate limiting, there's a high point, there's a high chance that the attacker will actually tear the server down. The server will actually be weak of taking in multiple requests, and from there you can just expose everything it has within its reach and say, all right, just get in. Just get in. But if there's rate limiting, it cuts them short, it cuts them out, locks them out, and not allow them to actually perform the action they want to do. Now let's check this vulnerable login endpoint. So vulnerable, no rate limiting, then attackers try milliseconds of passwords. Vulnerable, rate limiting by IP only. Attackers use distributed botnets with many IPs, no account lockout. I mean, you see, this is so short, just 22 line of code. That is very, very short. In fact, I would say 22 minus 1, 2, 3, 4, 5, like 17. It's just 17 line of code. That's actually bad. So yeah, login, request, body, attacker tries. So there's no limiting that after this multiple time of something, you should log them out. No. Attacker can try millions of passwords. Await authentication, username, 401, invalid credentials. So there's no after this particular amount of password, you should tell them to probably maybe suggest that they use the forgot password link or something. They are vulnerable, no rate limiting by IP only. Sorry, rate limiting by IP only. So attackers use distributed botnets with many IP. So in this case, there's actually a rate limit, but just for IP. It's just for IP. So they can actually use botnet with many IPs. So this solves nothing. Now for the secure rate limiting in brute forcing and credential stuffing, you can see. Now here we have just 22 line of code, and here we're having 52 line of code to actually stop these attacks. Okay. So let's go into it one way and see. All right, constant rate limit equals required express rate limits. Redis store require rate limits. Redis is actually like a kind of backend something for applications. So that taking a backend for application Redis. So layer one global rate limit per IP. So rate limiter, this global limiter rate limit. Then the Windows, yeah, window MS. I'm reading right. Yeah, window MS. This is the amount of time. The max of 100. That's 100. Probably 100 requests. Then this is limited per IP. So per IP, there's a particular amount of time that is given for every IP. Ready store. Then this code is something else for me at the moment. So layer two, strict login rate limit per IP. Strict login rate limit per IP. So for every IP, you only have 5 requests to drop. Then this is the window time. Let's see if it's the same with the, yeah, it's the same. So message, too many login attempts, please try again later. Of course, it logs them out for a particular time before they can come back into and try to continue whatever they are doing. Now, layer three, per account rate limiting. So you can see here, we have strict login limits per IP, we have global rate limit per IP, then we have per account rate limit. So for every account that's trying to attempt should be less than 5, should be attempt. If attempt is greater than 5, then lockout minutes. Then this is the amount of time that we use to lock out. Then request 4 to 9. I think that's too many requests. Error 4 to 9 is too many requests. Then it's account locked out for the amount of time that was set here. So that's simple as that. Then next, app post login global limiter, blah blah blah. Then capture after failed login attempts, failed attempts. Then it's capture actually brings in and say, let's see if it's a human being or a robot. And then you see those things popping up in your screen and saying that that's why you're a human being. So brute force protection strategies. So high period limiting, simple attacks bypassed by botnet or proxies. So this is the consideration. These are the considerations here. Then we have the protection against this strategy. So this strategy, account lockout, protection against targeted attacks. So can use DOS on account, distribute denial of service, capture automated attacks, UX friction, accessibility, then progressive delays. So this both sides and all. Now you can just come here and go through this authentication lab and see. I might actually drop a link in the comments in the description so you can access this lab. It's actually free, so you can learn as much as you can. So what is credential stuff in? Yeah, that's the answer. Account enumeration. Whew. Yeah, excuse me for that. Account enumeration. Account enumeration allows attackers to determine valid usernames or email addresses. So this information is then used for targeted account attacks like credential stuffing or phishing. Yeah, enumeration, trying multiple username and password in that account, blah 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 blah, to actually see if this one is real or this one is working or this one has been logged in before, and then you can try to bypass it. Now, this enumeration vulnerabilities, we have 47, and here we're going to have like 15, of course, but not that long though. Oh yeah. So here, mm, login enumeration. So this await user find by email. If user return status 401, user not found. This reveals invalid email. If the password or something is a incorrect password. Now, in cases like this, you shouldn't be given incorrect password. If a user drops in a username and password and it is the password that is incorrect, the error code shouldn't be incorrect password. You're already telling the attacker or whatever user are trying that the username is correct, but the password is incorrect. It should be incorrect password or username. So now this is actually placing a kind of confusion because you don't even know which one is correct. If it's also the password that is correct, you don't just come and say incorrect username. Nah, you be like incorrect password or username. You can say incorrect password and username. So this creates a very, very big confusion to them, and they won't know where to move on from there. So this error code, this error description is wrong. This is also wrong in some sort of way because you are telling the attacker that don't waste your time on this email. The user does not exist. Registration, registration enumeration. So after the register, the request, the response, email, password, body, then await user find by email. So email already registered. Given this kind of response that email has already been registered is a big flaw. They are telling the attacker that now the email is ready. So you can as well just allow the attacker to actually get access to this account by sending a phishing link to the user, because now he knows that there's a user using this application and this is the email. Can as well just say, we're trying to reset something, kindly click this link, and that's bam for that user. That's all. So this is also a very wrong response, by the way. Now, password reset enumeration. When click forgot password, this success through. All right. I don't know much how to explain this reset function because I think the error code is actually. mm, I think the better error title, the error message here will be email will be sent to this mail if the user exists. I mean, I think that should be the response that should be given through this please. Vulnerable time-based enumeration. So um this is time-based, by the way. So it says, so this is given that 50 milliseconds if found, 5 milliseconds if not. Of invalid credentials. I mean, this is vulnerable, yeah, but let's check the prevention methods. So generic error messages. So instead of giving this invalid email or password, that should be the answer. And for here, registration without revealing existing accounts. If this email is valid, you will receive further instruction. Now, this is placing confusion for the attackers and being like, oh, so we're not even sure if this email is registered or is not registered, which actually means them either waste their time or just drop it off totally. Now that depends on them, but you have to give the right response. Then we have here secure password reset without enumeration. If an account exists, a reset link will be sent. This is also a good response. Now, I think the vulnerability here is given the wrong response, the wrong vibe with the attacker, understanding that this exists and this does not exist. That is not in a good way to actually do given kind of responses. But this is going to give a standard requirement, like, all right, this is what you are going to do, and this is how it's going to be done. All right, then we have secure code, constant time comparison, constant time comparison. Require crypto, that's probably the cryptography encryption standard. Then constant time compare A and B, A len, B len, then this time safe equal buffer. When you see codes like this, I don't understand. You just copy them straight and BEM asks for instruction. That's why you should actually have a senior engineer in your team if you do have one, or else AI will end up being your senior security engineer. I mean, but yeah, this is constant time comparison, just comparing time and saying that all right, this actually works well. You can as well just look more into this. Then how can timing attack reveal valid accounts even with generic or error message? Timing attack reveal valid accounts. Database looks for existing user take different time than non-existing. Hmm, I guess so. Yeah. Now password reset flaws. Wow, that's a long one. Password reset flaws. Password reset functionality is a critical attack vector. Weak reset tokens, improper validation, or insecure delivery methods can allow attackers to take over accounts without knowing the original passwords. Yes, yes. So vulnerable reset tokens, date now, user ID, and I already talked about this token is guessable. The date of now is guessable. The ID and this whatever dash that is separating them is making it guessable. And then vulnerable short or weak tokens, 6 characters. I mean, this is not even a token that is even long enough to trigger anything. Doesn't make it secure. Then token never expires. We already talked about something not expiring. It gives them a very good edge and privilege. Then token not invalidated after use. After use, it should be refreshed. It should be refreshed, regenerated, so it can be reused. So token still valid, can be reused. Of course, this is going to be a great flaw. Then with security questions, what is your mother's maiden name? What city were you born in? What is your pet name? So these are known as risk security questions. So what should a strong security question actually should look like? All right, I guess we're about to find out. Then secure password reset. Require crypto strong random generation function. Generate reset token. So random. So instead of to string in just something should be in hexagonal. That should be like 8. In here we have substring. But here we have to string eggs. This like I think a kind of um encryption kind of thing, making it long something. Then talking with expiration, of course, yeah, adding a timing to it and making sure that there's actually a time for it to expire, not just a random, not just not giving it a time to expire. It should have a time to expire, and it shouldn't be too long too, by the way. Then store hash tokens, prevents database exposure from revealing tokens. Yeah, this also strong store hashed token. So this prevents database exposure from reveal token. So if this token actually hashed in hashed format, then database won't be able to review them and attacker won't be able to get access to them. So if valid, reset link sent. If not valid, it won't be sent. But then that message will not be popped out. So attacker won't know if it's actually valid or not. So secure, validate and invalidate tokens. This is a long one to validate and invalidate token, by the way. Hmm. But this is how the code is. So understand your code very well. You won't have issues when you're reviewing codes. In most cases, you can just copy this code and check it out. But then you won't want to do that, giving your code to an AI. So rather, use a tool to actually test for this. You can use tools like Sneak to test for security flaws like this, to check for code reviewing like this, and it will show you what mistake you're making and how you should get it done. So I guess I have the tool Sneak. Yeah. Snake, of course. Okay, maybe we'll check into it some other time. I guess I lost access to my former GitHub account, so I think I'll have to re-authenticate it with a new GitHub account that I just have. Um, mm. So automatically find and fix vulnerabilities in your code, open source, and container. So this is what Sneak's actually used for. Um, so that's actually very handful tool during a code review. All right, to run Sneak. So this way I can actually check my codes and check Well, I don't have any application hosted on my stuff for now. Can as well just check it. Complete registration. So in here you can import. Uh, um, nah. Mhm. Nah. I want to make this. Just integration method. Yeah, I think this would be best for me at this moment. Next step, public, private and public. Uh, yeah, password. Do I remember my password? No. Do you know what I typed there? No, you don't. Actually, a strong password, by the way. But yeah, we've gotten in and we are here. So this is how this tool works. You import your code from your GitHub or whatever you connected it with, and then you check if there's any vulnerability in that code. So import and scan your first project. Where do we import from? Your project. And let's move this like this. I can see clearly. Oh, it's loading. Okay, okay. Let's check this Python demo. Now let me check my portfolio and see this. Actually, just a landing page, but let's see if it find anything. Even for a landing page, I believe there should be some basic flaws there. But yeah, let's check it. This is just an example. All right, it has been imported. Now we're going to be seeing if there's any vulnerabilities there, low, medium, high, and critical. Uh, isn't there anything here? All right, 12 high, one medium, one low, no critical. All in package.json file. So here's how you check into it. After you see this, you can just click. Yeah, here's where the code is. The code vulnerabilities. You can just click into it here, then we check it out and see why this is not secured. Then it gives you recommendation on how to actually fix the vulnerability. So during a code review, this is a very good tool. But then you should never rely fully on automated tool or anything sort of. Manual might be slow, but it's still one of the most effective way in securing your code. So, all right, all right. Fixable issues 25. Wow. Okay. Uh, okay. Yeah, the vulnerabilities are seen. Next at 15.5 or 1.0. Next, HTTP request smuggling allocated. So yeah, the issues are same there in the package of JSON, but we can always look into it and then it brings a solution. Yes, and so this is not. Hmm. Well, this is not why we are here. Just a brief view, and we've seen that, so we can also just move away from there. So here's how you just work on your password reset. Now, password reset checklist, you check for strong tokens, cryptographically random, 32 plus bytes, critical. Priority is very critical, not high. Token expiration, 1 hour or less, critical. Single use, invalid after use, critical. That means the token should only be used once. Then after it has been used, it should be changed immediately. Then secure delivery, email only, not URL parameters. Rate limiting, limit rate request per account, then notify unchanged invalid sessions. Now the question, why should reset tokens be stored as hashes in database? If database is compromised, attackers cannot use leaked tokens. Yes, because now the tokens, the passwords are hashed. So, of course, if they are not something written in MD5 or so, then an attacker can actually can't do anything about it. So, prevention techniques we have here: password hashing, password policy, session regeneration, secure cookies, rate limiting, generic errors, MFA, yeah, MFA, session timeout, audit logging, breach monitoring, secure, comprehensive secure authentication implementation, comprehensive, yeah. Of course, I expected it to be long. What's the most important action after successful authentication is regenerate session ID. Yeah, that should be the next thing to do. So you can also further here by going upgrading and all. All right, next is IDO and access control. The previous we did JWT security vulnerabilities, of course. The next we're going to do IDO access control. But now we actually know the major things in securing authentication vulnerabilities in web applications. So we can as well just furthermore. And now I said we'll be doing a lab. So let's go on straight and start solving these labs. All right, I think my 32. Okay, should be more than enough. Then we'll come here to lab. Alright, not JWT. I'm going to the authentication. So here is ports figure. Here is the ports figure, a place to come and solve vulnerabilities lab and also, check to also understand how to solve some of these labs. This is a basic labs. Might also largely be outdated, but then it gives you the basic knowledge you need when you're trying to solve any vulnerability. Let's check for authentication. All right, here it is. So there are four labs I've solved here actually. I didn't have time to actually solve the rest, but maybe later on throughout the day we'll try to solve it all. So all right, username enumeration via different responses. All right, this is one of the enumeration methods we're talking about, that being able to enumerate password policy, passwords and username. So this has given us the candidate username and candidate password to actually use in enumerating this thing. So we'll be using this to actually, I'm using a tool called intruder and buffsuits to check for this. So let me go in and clear my logs on buffsuits here. Yeah, delete. Then here, delete. I should actually give it a kind of target. Um, but target target portfigure.net, I guess. But now to access the lab, is this a given portfigure.net? Yeah, let me just go give it portfigure.net as the target. So dashboard, no, target scope. Yeah, I'll give it a scope. Then how to scope. Encode subdomains. Yeah, let me add just normal portfigure.net. So what I'm doing here is making sure that every proxy I collect is solely from this endpoint only, from this website only. So every other thing from every other endpoint, I will not receive them. Okay. You can see now it has stopped. So when I come here and let's test if it's actually working. Okay. Let me reload. Reload. Not finding anything. Okay. I guess I should have had this to the endpoint as well. But when I reload this, I'll get it. Of course. So I have to add this to the endpoint as well. Because I want it to be filtered. I don't want too much things popping up on my screen. Okay, then add this. I should include subdomain as well. Did okay. So I guess now I should have it. All right, yeah, I have it now. Now I have it. I have them all. So we'll be doing this username enumeration. So first of all, I have to here are the usernames. Of course, you can always get list from sec list also for usernames, popular usernames they're using when you're doing a proper pen test, like a proper pen test, or you're doing bug bounty hunting and try to test for username enumeration and see if this application is vulnerable to the same thing. You can always use it to check. So Base Lab is vulnerable to username enumeration and password brute force attack. It has an account with a protectable username and password which can be found in the following word list. So solve the lab, enumerate a valid username, brute force the user's password, then access their account page. All right. Now there is the stuff. So what I'll do here is come to my account, then I'll try to log in with whatever. The popular one is actually winner, then Peter. Let's see if winner Peter is still valid. Invalid username. All right. Invalid username. So of course the password is not correct. So I come here and scroll. Here's the login. Um, yeah, all right. So we have username here, and then consent to intruder. Yeah, send to repeat and send to intruder, just in case. Okay, the account, my account is here. Found. All right, that's not what I need actually. I've taken what I need, and here it is. So I have intruder here. And here it is. So in this place, if you have not know how to use Bob Suits, you can actually check one of my YouTube videos in which I actually identified and showed how to use Bob Suit properly during a pen test. Now I'm going to be doing this. So we're trying to enumerate the username first. So we copy this username, we do this username in this way. We had, which means every username will be testing, should only be testing it in this parameter. And I can just paste. Yeah, I can paste. Remember, this payload type should always be in simple list and also be in sniper attacks during stuff like this. So now that we've gotten this, can I add from list? Oh yeah, there are lots of lists I can add from actually. But yeah, this is not what we're doing because the design is probably not in this place. So let's start the attack. And let's see how happens. So we wait. We wait. It actually takes a long time. We wait and see which one is correct. Okay. It's enumerating them all. Hold up. Finished already? Wow. Okay, so which one is actually the right password, the right username? Now, how do I even know if the username is correct? I guess I should do this way. Response received. So I'm should be looking for like a kind of response status code of 301 found. So there's no found here in any way. Let's check here as well. Okay, I don't know. Is this correct? Yeesh. Now, I think, okay, okay, probably that should be the password, the username. I should be seeing a 301 found, but I'm not seeing any 301 found. So, how do I know what the password is? Okay, this is why I do not really like fixed labs. just give some kind of different issue. Let's check what they actually have here. How are we going to get it? Yeah, yeah, done this, done this. Yeah, okay, okay. Then length. All right, what's it saying here? Examine the length column in the result table. You can click on the column and to sort the result. All right, let's check the length table. Yeah, here's the length. All right, 3352, 3352. I guess we picked one that is longer. All right, 3354, 3354. I guess here is it. 3354. Here's the longest length we have. So the username is probably ADM. Let's confirm that again, by the way. Length column result. We can click on the column header to sort the results. Notice that one of the entries is longer than the others. Compare the response to this payload with other responses. Notice that the response contains message invalid username, but response is incorrect password. Okay. So what it's saying is this will be giving us invalid. The remaining responses will be giving us invalid username. But this will be saying invalid password, which means the username is correct. But then how do we check the response? You need to check it well. Um, let's check invalid, zero matches. There's no way bringing is invalid anywhere here. All right, let's check it. Okay, let's go test it then. Let's go test it on the website, on the lab itself, and see if we actually got something. So ADM, then password could be anything. All right, it means this username is actually correct. You know, when we type the last one, it says invalid username. But now we type the password, the username we found, and it's saying incorrect password. So now we already found the username, and this is how it does password enumeration. This is how enumeration actually occurs in stuff like this. So we've gotten that. Now we can just cancel this account, discard, then come back to the normal stuff. Now we already know the password is correct. So let's go get fresh tokens because we're not even sure if that thing actually changes. So cancel this out, come here, login, come here to the login. Yeah, there it is. Send to intruder, come to intruder. We have the username. And now for the password, yeah, I use Gabitech, so add this. So this won't be using the one we used the other time. We take a new enumeration for the password. This for the username enumeration. So let's go check for the password enumeration. Um, okay, so copy. Why does it have to be so long? All right, so here we have it now. I take this copy and I will come here and test for it. You can see what it's here. And now it has not been pasted, so we can try and get what we're doing. So now all this password will be enumerated in this password parameter alone. And when we get the answer, it's going to give us the kind of status code that makes us know that, yeah, here is the answer. Now we ought to actually solve more than one lab, but one lab is already taking all the time. So let's see. Oh, finished already. This one is not taking any time. All right, so how do we get the last one? We use the length to determine, and now we're having multiple lengths here. Of course, we have 3354 and we have 3441. So I guess the length is not what we'll be looking into to actually check for this. Okay, we have 185. This is the smallest length. That's actually weird, considering the fact that we have length that are identical, and we have 302, and status code 302 means found. So which means that this password is the correct password. Now we see status code 200, 204. But this is given 302, which means it's found, and which means the password for this is pass. Yeah, pass. So let's go log in that account and delete the user. So pass and ADM. So ADM and pass. Now log in. and bam, we've solved the lab. No thanks. Now we've solved the lab. Now this is how password. That's what I'm talking about. Now I was saying the other time that your browser has to bring it for you if you are using a password that is actually weak. So this password you just use have been found in data breach. So update your password. Now this is actually a good. That's what I'm saying. If your browser isn't bringing this for you, then there's a problem. So now this password this lab has been solved, and we've just tested for the username enumeration, and that's the lab we found here. Account enumeration in this place. Account enumeration. Account enumeration allow attackers to determine valid username or email addresses. So this information is then used for targeted attacks like credential stuffing or phishing. So this is that aspect. Now I'm going to be going into another lab to explain one of the things we've solved. We talked about here. So 2FA simple bypass as password reset broken logic. Username enumeration subdivided responses. Okay. Let's check for 2FA simple bypass. I think we talked about 2FA. Did we? Did we touch? No, we didn't. But this is password reset flaws. So let's see. But there should be a password reset. This is a password reset broken logic. So let's solve this one instead of the 2FA. Let's solve password reset broken logic and see how it's done, how the password is being reset. All right. That was actually I actually took a break in between, but let's continue. Okay, why is my face not showing? Let me fix that right away. Okay. All right. Oh, now it's even dark. Uh, let's see if this helps. All right. Yeah. Okay, now I can see me. All right. So let's work on this password reset broken logic as it's actually variant with is correlating with what we discussed in the code review lab, and here we have it. So we come here. So this lab password reset functionality is vulnerable. To solve the lab, reset Carlos password, then log in as and accesses my account page. So this is my credentials and this is my victim's username. So I'll be logging in now and let's see what we can do from there. So access the lab. And yeah, remember, I think, all right, let's cancel this intruder. I believe we still have our stuff here. Okay, let's go log in. Discard my account. Username, winner, then Peter. So let's log in. No thanks. All right, this is my username. No thanks. No thanks. So email, here's my email. So let's come here. I've actually not even seen how to solve the lab. One thing about vulnerable lab is that there's a specific way in which you have to solve that lab, and that's actually a very tiring aspect, especially in terms of support figure. You can't even use your own way to maneuver it. You have to follow a very distinct process to get things done. But let's see if we can actually find this before without checking what we are told to do. No, 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 no. Oh, now we have a different lab. I need to copy the lab endpoint and add it to the target scope. So I'll log in that again. Log in. So should have captured that. Okay. Send to repeater. So here we have the login, my account. Let's see if I can get where I actually imputed the login and all. So the password itself broke, the logic here is broken. But let's check if this Carlos actually exists. So well, we know it exists, but let's verify. Let's go. All right, found it exists. So let's take it back to winner. No, Z. All right. So what do we do from here? I guess the next thing we do here is to go check. Is to go check the reset broken logic. So let's update the email. I guess there should be something here beneath for us. So update email. And yes, uh, email has been updated. Email has been updated. Yeah. Why is this not showing? Okay. So let's come here. Where is it? Where's the one I'm gonna say it? Getting distracted here. Alright, I've changed the email. Here's the email. Here's the account ID. So let us give it a color just in case we want to come back to check something from it. Okay, give it here too. Alright, now we've given it the colors. So let's go and check for reset password. Now I believe what we'll do here is I guess we'll log out. Then try to log in. Then click on reset password and see what we can do. Alright, so Carlos, so forgot password. So I guess I click this now. Okay, username. So use Carlos. So I guess this is the email clients are going to check in. Right, I guess this is the email we are meant to submit. Okay. All right, let's go back and go back here. So let's put in this email instead. Let's put our email. So now we can check here. Reload this. Okay. To reset your password. So let's see. Click on it now. Okay. New password. Uh, Carlos. Carlos. Hey, so Carlos. Login. Alright, still invalid. I guess I didn't do the lab right there. I didn't solve the lab correctly. Let's see. So let's log in back to winner. Then Peter. What? Hmm. Oh, I reset the password already. So it's going to be Carlos. No. Okay. Okay, so let's go read on how to solve this damn thing. Cause okay. Hmm. Okay, yeah, this is the way to solve it. The funny thing is that I actually solved this lab, but you have to follow a very direct process in bypassing in doing this password broken logic lab. So here we have it. It says with Bob running, click forgot password link and enter your own username. Click email client button to view the password reset email that was sent. Whatever you want, go to Bob. Alright, I guess I'll reset my password. So let me go and check Bob and see when the password was reset. I guess I should do this all over. Yeah, let's do it all over. Delete. These are the kind of issues we face when you're trying to solve a lab the same way. But we're trying to explain the password reset local logic here. So I guess we're bound to face some others. Right, let me go over this too, because I guess it's going to be a new something. So add it, include, okay, come back to proxy. So with Bob running, we come here and click the forgot password immediately. Here's the email, we submit the email, submit, then we get our email. Hold up. Okay, here's the new email. New password. Pizza, then pizza. Alright, so after that, what's next? Yeah, it says in Bob, go to proxy, HTTP history, and storage the request and response for the password reset. Observe that the reset token is provided as the URL query parameter in the reset email. So I'm coming here now and saying where this password reset email was. Right, then come here to where the password reset email was. Right, here's this. Okay, here's the token. We got the token now, so send the repeater. Uh, okay, we've gotten the token we want to get. Now, what do we do here next? Okay, because continue username as hidden input, send this request to Bob Repeater. In Bob Repeater, observe that the password reset functionality still works even if you delete the value of this. Alright, so let's delete it and see if it still works. So they said when we delete this the value of this, that should be this token here. Then send. Alright, it still works. Still works. It's meant to have stopped working. This compound that the token is not being checked when you submit a new password. Alright. So in the browser, request a new password reset and change the password again. Send it to Bob Repeater again. Okay. Alright. So delete the value of change the username parameter to Carlos, set the new password. Okay. So what we have now is going to reset the new password again. Then where's the email client? Here's the email we're sending it to. Alright, I guess what this is what we're doing. Then we set this to Carlos. I guess. Yes, that one meant to do. Okay. I'm not changing it here. So submit, changing again, coming here again, reloading this again, getting a new body, then setting the password again, Peter1, Peter1, submit. Then we come to pop repeater here, take the new stuff, send it to repeater again, then come here and change this card winner to Carlos, and then we send a request. It works. So I guess we'll copy this URL, we come here, and we'll solve the lab. Wow, this actually is tiring. Okay, so I have to delete this parameter, token parameter value, and delete it here too. Then I send it again. Still works. So I copy the URL, request in browser in current section, copy, come here, open a new tab, paste the link. It's requested, changed, and no. Hmm. Oh, change the username parameter to Carlos, set the new password to whatever you want, and send a request. Alright, we send the username to Carlos. So I guess we request a new password. Alright, so I guess this time we just have to log in, not changing anything. So say Carlos, then Peter1, and log in. No thanks. And yes, we have solved the second lab. Took quite a kind of time. So to explain that, what was happening in a nutshell was the request parameter that we used to change the first password of winner. It's here. So let's explain that again. For it might sound confusing. So this is the first parameter that we got, and here it is here. We saw that this token here was even if it's deleted, the stuff is still working. We found out that this reset logic is still working even if the token is removed. Then what we do was remove this token, then remove this other token up here, and we just change this username to Carlos. So it means, and we sent it, and it's actually accepted the request here, as you can see, which means that we've automatically reset Carlos' password to Peter, and now we can now log in as Carlos, just because the reset logic was broken, and that's because the token is not actually validating anything, just there for beauty's sake. So these are the kind of vulnerabilities we find in broken authentication, and we have some more other labs there. 2FA bypass, username enumeration via response timing. This is where rate limiting actually comes in. Brute force protection, IP block. So these are the other labs you can actually go into and learn from, and also sort to understand better in what this broken authentication code review lab is talking about. So thank you for sticking to the end of this YouTube channel. If you enjoy what we're posting out there, don't forget to like and subscribe to this YouTube channel for more videos, engaging and practical insights like this. The